Welcome everybody to another edition of Dappnode Crash Course. Which Dappnode should I buy? So there are a lot of questions when you want to get started as a non-technical user. Usually these questions start with hardware, like how do I know what I need to run a validator for this network that I want to participate in? So today we hope that we are able to clear some of these questions. So, okay, let's get started. What is Dappnode? It's an operating system that allows you to run your own nodes in an easy way with a user interface. We usually come in two flavors. You either have Dappnode installed from one of the Dappnode home devices that we sell in our shop, or you install in your own hardware. You basically get an app store where you can install more packages. You get a stakers menu where you get to pick your clients. So what specs do you need for running this kind of software? Some of the minimum specs that we recommend are 16 gigabytes of RAM, a CPU from the core series, and at least 2 terabytes of storage. So you could say that with the minimum specs that you need to run Dappnode, you are able to have a very, very basic setup that you'll be able to run an Ethereum mainnet node with. However, if you go to the minimum specs that we offer in Dappnode homes, you'll find the Hopper model that comes in 32 gigs of RAM and 2 terabytes of storage. So this way you are able to fit another EVM network, such as Luxo or the Holesky testnet. And then from there, you have the 2N model, which is basically the same as the Hopper model. And from there, you have an increase in 4 terabytes of storage for the 4N model. At last, we have our most powerful device, which has 64 gigabytes of RAM. So down here, you can see what are some of the minimum things that you can run in these devices. So we're going to talk about how can you have a clearer idea of which one is the right for you, because maybe there's a way in which you are able to get away with the minimum specs. In the end, I would say that this is a matter of experience as a node runner. So in the end, this experience I think is the most valuable, the one that you have as a node operator. How can you get closer to know exactly what you need? Well, as you may know, for running an Ethereum node, you need two things. You need an execution client and a consensus client. Then if you are running a validator, optionally, you can install Web3 Designer and MEV Boost. But for getting a functional node, you only need one of these two. So how does each of these options impact the specifications that you are going to have in your Dappnode? This is where it starts getting interesting because it depends on a number of factors. It depends even on the code that each of the clients was written and how efficient it is with specifications. While I was researching for this crash course, I found this website. It measures the popularity of programming languages. So as you see, Python is by far the most popular language. However, it's known to be not as efficient as other languages. So efficiency is something definitely important when it comes to clients and validators. So yeah, we're gonna talk a little bit more about these languages. When we talk about client resources and the minimum requirements that these have, you'll find that Geth, and this is from the documentation of each of these clients. So Geth is written in the Go language, and it asks as minimum requirement 16 gigabytes of RAM and a quad-core CPU. In the case of Prism, we're talking about the same. It's a consensus client that is written in the Go language. And then we go to Nethermind that started implementing .NET, so it's written in the language C. It also asked for a quad-core CPU and 16 gigabytes of RAM. I think the Nethermind team has done a great job bringing this number down, because I remember older versions of Nethermind that used to use a lot more of your RAM. So I think this is one of the things where they have made a lot of improvements. We also have Lighthouse as a consensus client, which recommends a quad-core CPU and at least 32 gigs of RAM. But it is also written in the Rust language, which has been growing its popularity because it's just very attractive to blockchain technologies in general. So I have some experience running it, and it is very efficient, but it also runs with constant specs. So if you have the minimum required, I think you'll be okay for running Lighthouse. Then we have Aragon, which is an archive node. Being an archive node, you'll need significantly more storage to be able to allocate this. But the cool thing is that they recommend very low specs. So as you might have noticed at this point, each of these clients are kind of like a give or take thing when it comes to the specifications. So what if you're putting together a node and you don't have a great CPU and you don't have a lot of RAM memory, but you happen to have a lot of storage available? So this could be useful for an archive node that uses Aragon as its main client. So this is just an example of how this works when designing or choosing which specifications you're going to have for your Dap node. Aragon was rewritten from the Geth code, so it's also based in the Go language. And then you have Teku. Teku is made in Java. This is, I think, the consensus client that will take the most RAM memory from you, but at the same time, it's one of the ones that have more successful reports of successful attestations for home stakers. So this is something that Teku does a great job at. And they also recommend a quad-core CPU. Then we also have Besu, which is an execution client also made by Consensus, just like Teku. And it is also written in Java. And they recommend 64-bit architecture and at least 32 gigs of RAM. Then we have Nimbus. Nimbus is the lightest client available. So this one will go very, very smooth with 16 gigabytes of RAM. And it's also written in C, just like Nethermind. So what does exactly happen in Dappnode when you're running these clients? So as I mentioned, you need an execution client and a consensus client to be able to run an EVM node. Then another very common question is, how many validators can I run in a single machine? The thing is that since proof of stake works differently, what is important when validating in these kinds of networks is that you actually maintain the sync, because your validator is going to be performing attestation duties, and the first thing it needs is a synced node. The most important job that your Dap node must be doing when validating is keeping in sync. And this is not something that is helped by the fact that you have better specifications. Like this is not proof of work. More resources doesn't equal more income. It equals better performance. And if your performance is good enough to keep clients in sync, this is everything that your validator is going to need. So for each validator that you have a key store that needs to be talking to your consensus client in order to attest. And this is managed in Dappnode by Web3 Signer. So if you have Web3 Signer, like we're going to go to this Holesky one as an example, and we're going to go to the Staking Brain UI. And here we'll see that we have these different validators loaded. So what each of these are doing is checking into the consensus client in order to be able to attest and do the signatures in the window of time that it has. If this Dappnode is doing a good job maintaining sync, this is everything that the validators are going to need in order to be able to attest. It really doesn't have a lot of impact in RAM memory. When you load a new key store, you can be loading hundreds of key stores before you notice a difference in the RAM memory. So it's also a good idea to save memory, like allocate your resources in the right way. Like you don't want memory to be on the top red levels when you are about to sign the proposal of a block. You don't want your resources to be busy when it's important that they are available. But you can also be playing around with your clients. Maybe you are running very low on RAM memory, but you are using Teku as a consensus client. So maybe switching to Nimbus can help bring down your memory and therefore have more availability and allocation of resources in order to perform your expected validator duties. And then you also have other options. Like if we go to the Dapp Store and we go all the way down, we see that we are able to install a Bitcoin node. This is something that people like to support because not only they will have access to their own node in order to make and submit their own Bitcoin transactions, But it's also a great way to support decentralization. I mean, I was checking on bitcoin.org some of the specs that you need for running a Bitcoin node, and these are heavily outdated, at least at this space. So this number might be a little bit outdated, but the rest of them are pretty accurate if you're worried about impact on your CPU and RAM memory, which are more important to be able to attest and perform validator duties. And also you have other kinds of stuff like Hopper, and you also have Swarm. Mysterium is also a good one. You rent out your network as a VPN and you get paid in Mysterium tokens. There are many options that you can try out, and it's always going to be about the impact that it has in your specifications and how you can take good decisions allocating your resources